questions later on, in which case stick your camera back on and come off mute. But for now, if you go to mute and stick the camera off, it just gives a better focus for our speakers first thing in the morning. Okay, so we've still got some folks joining, that's fine, but we've got a lot to cover this morning. We really want to bring that to you, so let's get ourselves going. So welcome to our breakfast briefing, a little bit different from normal. We're really pleased this morning that we're bringing this morning's breakfast briefing in partnership with the Institution of Engineers in Scotland. Real thanks to them for coming forward and suggesting we do this. And as I'm sure you're aware, because you've signed up to come, our theme this morning is about successful innovation. And to do that, we get a chance to celebrate a couple of things. First of all, we get to celebrate the fact we have the founder of Optos, Douglas Anderson, with us. And he's going to talk about the multiple threads of innovation that it took to get his company going. And then we're going to hear about what it takes for a company to then take on the baton and run on with it and keep that thread of innovation going. And Derek Swan, the Chief Technology Officer at Optos currently, is going to speak to us for that. I suppose I'm really pleased that we get to do this. Optos were one of the first companies I got to visit when I joined Scottish Engineering in this role, and I was just blown away by the technology and the attention to detail, the manufacturing excellence that they have at their site, their design principles that lead to that. And they were, in fact, an award winner from Scottish Engineering in, I think, 2019. It's a real pleasure to have them here. And if I didn't mention already, it's a big birthday year for them too, because this year is the 30th anniversary of Optos. So with that, it's time for me to stop talking. I'm going to hand over to Douglas Anderson, and he'll take us through his presentation, and then we'll hear a little bit from Derek after that. Douglas, I'll hand over to you. Thanks.
Thanks very much, ladies and gentlemen. It's a pleasure to be up at 8 o'clock in the morning. I don't normally do that, but being semi-retired now. Nice photograph here taken on the Glencoe Road, crossing Rannoch Moor. I have a backdrop as a mountaineer, which is odd that I should perhaps mention it, but it is relevant. So I'll trot on here. I'm going to cover the following points. So why bother? Why did I bother to develop the retinal imaging system? What's the fundamental value proposition, which I hope I'll be able to explain to you, because the difference between Optos technologies and would-be lookalikes is in many senses quite small, but on the other hand, hugely important. Then I tell you how we innovated the technology, because we didn't have any technology. It was a genuine zero-stage operation, and how we staggered forward financially, because it's a big technology, very complicated. It took us 20 years really to implement, to discover, to innovate, and to implement, to realize the design intent, and how along the way we were nearly killed many times really by complex issues with the supply chain, and how finally we managed to penetrate the marketplace and medtech technologies, particularly if they're very innovative. The inertias are very considerable, and if you come from a backdrop as we did, which is no clinical connection, no KOLs in the sector, ophthalmology or optometry, then they're especially difficult, especially if you're putting forward a device which is an order of magnitude more expensive than the status quo. So some of you may know that my son lost the sight of one eye when he was just 5 years old. Prior to that, he required vision correction of -15 diopters, so he was extraordinarily short-sighted, which put him at high risk of having a retinal detachment. Something we didn't know as parents, because that was in the days when it was for doctors to know rather than patients. Anyway, he lost his retina, became detached at some point because he wasn't being examined competently. The retina was off for too long a time, such that it became dead and corrective surgery was ineffective. Just reminding you a little bit about the retina and its role is an interesting piece, really, of brain tissue that pokes out through a hole in the skull. A bunch of photoreceptors, 120 million rods and 6 million cones, and light is focused on them, of course, by the front lens assembly. Now, that's kind of important in terms of the technology that we had to develop, because this is a variable system, the front of the eye, cornea and natural lens, and it changes shape and it's very patient dependent. So if you want to look at the back of the eye, you've got one component there which is different patient to patient. This is a real image generated many years on from the start of the project of a patient who has the sight of the type of retinal detachment that my son had. So a large retinal break and a full-blown macula off detachment. So putting that back on quickly is pretty important. I got in a little bit in the top left corner, it says, ouch. But actually, retinal detachments are totally painless. And that's a problem for identification, especially in kids. They will work round the gradual reduction of sight and they won't complain. If you ever have a descending curtain, this is probably a retinal detachment. As you get older and you have your vitreous begins to shrink, you can be at risk. Anyway, moving on from that. This is a strange picture perhaps, but it's material. This is us, the Anderson family, drifting down the Yukon towards Dawson City. Yukon's about 1,800 miles long, and we, after Leif's failed surgery, normally we had expeditions into the Arctic every year as a family, and we were quite well equipped for that. This year, after the surgery, it was too late to package our equipment to send it north. So it's at this time, drifting down a river is a great opportunity to contemplate what's been going before. And obviously, it had been a terribly stressful period. And here we are on a little unsupported trip down the Yukon. And it was this phrase here which kept coming back to me. And this was something that my son's surgeon said to me when I took him to task over what I thought was a poor quality manual exam. And this Hector Chola was a leading surgeon nationally and perhaps even internationally at doing the type of surgery that my son suffered from. Now, he told me that, and consequently, I didn't believe him. But it's something I learned over the period of time that when he said I was lucky to have him as a surgeon for my son, I thought that was just a ridiculous thing to say to me. But actually, it was true. And he said, after having done a manual exam of my son, not under general anesthetic, but just lying down, my son lying down. And I challenged him because he said that my son was doing fine. And I said, well, I can't believe that. And he said, that he had this phrase, "You must understand I'm only getting a glimpse." Now, this is fundamental to the rationale behind Optos. This is one of the UK's leading surgeons. He's examining a child and he's only getting a glimpse. This is 91, 92. And I had a background in technology, product development, MRI, CT, ultrasound. And how come we were relying on manual examination using a head-mounted torch and a handheld lens? It didn't stack up to me. And this phrase kept me going year after year after year when people said, you know, what you're doing is nonsense. You're a charlatan. In fact, an extravaganza of charlatanism is how we were described at one point along the way. So we were not welcome in the space, let me say that. But here's an overview of looking at the retina using a direct ophthalmoscope, which is the thing the doctor has. That's the field of view that I've just projected there. And if you want to look at the whole retina, and bear in mind, if it's a detachment, it's probably going to be in the periphery, there's 400 visual fields that you have to apply your tool to, and then memorize or build the picture in your mind's eye to say whether the patient has a problem or not. So clearly that's a very, very unreliable and poor method of retinal examination, but it was the standard tool for 90% of practitioners at that time. If you don't dilate the pupil...
You all right?
Are you hearing? Are we good? Okay.
Yep, good.
Good. All right. That's the field of view. So huge amounts of disease will go undetected outside that. This guy here, he was the inventor of the most advanced tool, which was very hard to use. And that surgeon, Chola, was an expert in it. But you can see here from this little chart that doctors' skills were very different dependent on just their manual dexterity, their ability to concentrate, and the cooperation level of their patient. If you are taking photographs, here's 40-odd photographs, which is torture for the patient, just a completely impractical thing to do other than for research purposes. So here's the design intent. I want to get the whole retina, no dilation. That's very, very important, because you dilate a patient, it won't be done on the high street. It has to be really easy for the practitioner, the technician. And from my perspective, I want it to be so easy that a child of 5 could do it. And that's a very lay explanation of the value proposition of any technology that would get through the gate as far as I was concerned. But if you could develop a technology that would do that, then it would ensure that all patients, regardless of their age, would have a competent eye exam, retinal exam, every time they visited a practitioner. So here's basic fundamentals. You're looking at the inside of a 25mm sphere, which has a variable lens in the front of it. You probably have to look through a hole less than 2mm diameter in some cases. You mustn't touch the cornea because the patient won't like that. You must use low light, otherwise the reaction of the patient, particularly with children, will be a big negative. And you need to acquire the image in less time than it takes to blink. And of course, retinas are designed to absorb light, not to reflect it. So you're going to get, if you put in light of the smallest possible amount, so as not to disturb the patient, then you're going to get a tremendously small amount of light reflected back. Now, along the way, various others who had more credentials than we did attempted to solve the same problem. It's true to say that they might have executed an ability to montage wider fields of the retina, but the complexity and the lack of ease of use meant that they were unsuccessful. So they were a reminder to me that the refinements of my specification were absolutely vital to make the project worthwhile. Otherwise, we might as well not bother. So here's our assets. So this is in Dunfermline, where I had a design consultancy, but we had no optical engineers, we had no manufacturing, we had no marketing, and we certainly had no money. The group of folks here are the team that I assembled, including some of the early stage investors. But we started with absolutely nothing other than a knowledge of the product design process. It was determined by those that knew better that technologically it was impossible, and in any case, it was unnecessary. But obviously, I had a strong belief because I'd seen it with my own eyes and I'd seen the consequences. But that my motivation didn't carry well into the venture capital world. I had raised money before for a project in CT, so I knew the marketplace, if you like. But over the period of 10 years, I was knocked back approximately 400 times by every venture firm, at least once in Europe, UK, and North America. However, I did manage by luck to encounter and lasso some very supportive private individuals who became the backbone of not just Optos, but what became the Archangel private investment organization, which went on to back a huge number of what you might call dodgy early stage investments, many of which have done very well. But I twisted their arms on a great many occasions over a considerable number of years before we finally launched the company onto the London Stock Exchange in 2007. Now, I'll just say a bit about the core of the technology itself, which is the patent which we stumbled across, if you like, very early on, but rejected, was to deploy an ellipsoidal mirror. And the thing about an ellipse is it has two foci. If you bash a beam of light in through one focus, it'll come out through the other. That is a core, or the core, to the ability to image the inside of the eye in our case. It allowed us to essentially place a laser scanning system effectively in the pupil plane of the eye, which I tried to show here. It's too complicated really to explain why other solutions didn't work. We tried many over a period of 2 years, 3 years before we came back to this original concept and began to engineer it from that point forward. Conventional imaging, in order to get wider views, requires you to bring your lens system closer and closer to the cornea until you touch it. And that invalidated many approaches as far as I was concerned. This is just some data just to show you how small the signal was that we were trying to capture and deal with in order to construct a whole image. You can see there we start off with less than 200 nanowatts average return signal. We're making 10,000 lines per second in order to generate a full image within the period between blinks. Here's another rendering of showing the scanning laser system, which we deployed. There are few components really, but each of them was destined to give us enormous complexities in order to construct them, because in order to produce an image of sufficient resolution, the precision with which the parts had to be made was beyond anything, and when I say anything, anything including military specification. We required components which were beyond military spec, and clearly this was very demanding on suppliers. Their test equipment simply wasn't up to it, and our knowledge of what was required also wasn't up to it. So here we go. You can see here how over the years our poor investors were required to pour money in pretty much every 3 to 6 months, because they weren't equipped to say, as might be typical with a dot-com company, they would raise 40 million pounds or something. We were raising 400,000 was a good lump of money, but it wouldn't necessarily take us very far, and we'd stumble across problems which we hadn't envisaged. But eventually we did produce whole or almost whole retina images of the retina with a non-contact, non-dilation system. And this was, I mean, it did take many years. I think really 10 years before we got anything that was adequate, and 15 or more, arguably maybe even 20, to reach the full-blown design spec. And here is the first device, the P200TX. It's a big machine. And you can understand here now, you can compare it with this little handheld device costing a few £100 versus our very substantial, I think 75 kilos, something like that, imaging system, which, well, if we sold it for 70, 80, 90,000 pounds, we wouldn't make much money. They were very difficult to make initially, and we had reliability issues. But at the end of the day, if they worked magnificently, and they brought even the worst machines we ever produced outperformed the average clinician by at least an order of magnitude, so that when people got them, they wouldn't let them go. And if they broke down, then they would stop doing patient exams until we managed to fix them. Now, one of the things which was material is that we sold the devices principally in the United States, because that market was open to us. There were acceptance of new technology. It was, I would say, 25 years from the get-go before the NHS, for which the product was essentially designed, actually took the product in any quantity. There's our first unit going out of our backyard in Dunfermline. And you could see here the blocks on the right. It did what it claimed to do. It made clinicians competent consistently. And in the management of diabetic retinopathy, it proved to be a great boon to improve detection of early stage disease. And many clinical papers have been written about its competence in this field over recent years. So it has now become the gold standard. That funny looking shape in the middle, it was the highest standard of conventional examination, which you can see only covers a small portion of the retina. Oh, that's telling me I've done 20 minutes. Time flies, isn't it? Here's a couple of components which just about killed us. The rotating polygon and the ellipsoidal mirror. They're very, very difficult to produce to the level of precision that we required. There was no manufacturer of ellipsoidal mirrors when we came up with our requirement, and so the manufacturing process really had to be developed, and getting the precision and the optical reflectance was very, very demanding. Typically, the first manufacturer could make 2 or 3 components per month, but we grow them by electrical deposition. But it was successful. With 30 years on, we still struggle a bit. So there's no room for complacency, even at this stage in the game. And a tour of our factory now would show you just how careful every aspect of construction, supply chain management, how tight each aspect has to be. And these polygons that we see here, this is the device which produces the high-speed scan, creates a spot into a line. We thought this was an off-the-shelf component. Regrettably, it turned out not to be so. And we discovered when we got into manufacturing, the yield is only 15%, and all of them broke within 12 months. So that was a ghastly problem, and ghastly from our cash flow point of view, to try and overcome that. And indeed, we had to start making them in-house, since we couldn't find a supplier at that time. We now outsource them, but it took a long time. There's just another picture of it. Patient positioning. We wanted the patient to position themselves intuitively, plus or minus 1/4 of a millimeter in three axes. So that's a demanding technological challenge in itself. But this patient obviously isn't doing it themselves. This is a very young patient, premature, 26 weeks gestation, and no dilation, and we're able to capture an image of the whole retina. Very important in the management of retinopathy of prematurity. And these are just a couple of other conditions. This patient has leukemia, undetected until the arrival of Optomap, 14-year-old girl, as I recall. This patient has a cholesterol embolus, a stroke risk of 100% in 10 years if it's not managed. Very simple to manage. And this patient have these manifestations which are indicative of colon cancer. That's our manufacturing floor with some devices that Derek will tell you about in a minute. So there's a bit of a repeat here. So just getting the device to market, we completely overcame the capital barrier by giving the products into locations completely free of capital cost and charging a small fee every time it was used. Very effective way of introducing the product, but very capital intensive on us. So tens of millions of pounds were borrowed in order to give devices to doctors for them to come to understand the benefits. And we had to roll out an entire support team. Love your customers, I say. Right across the US. It was fabulously expensive with helplines and, in fact, teaching the customer about retina, since many of them were pretty clueless and were actually afraid of discovering the disease. And of course, during that process, we built up many long-term relationships because we dedicated ourselves to doing that. So after 20 plus years, many doctors are still with us right from those early days till today, and they may be on their 4th generation of machine. And of course, we began over time to build clinical credibility. These are test sites within research hospitals across the United States. And during these stages, we developed new applications, new modalities to uncover new information about diseases. Ultra-wide field autofluorescence imaging. This is fluorescein imaging, where you introduce a dye and you can see that half the vascular system is essentially destroyed here. And this is an image of the retina which is actually using its natural autofluorescence. Anyway, I'm going to hand over now, or very shortly, to Derek. That business model, which was responsible for launching our equipment for over the first 10 years, as we became more credible, we migrated to a capital sales model. So people do now pay 100 grand or 70 grand or whatever it is to buy our devices. So we've got over 22,000 sites in operation. We've certainly done more than 200 million patients, which is a lot considering it wasn't necessary. This is one of my proudest moments when I received this book from a surgeon in Japan. It's entirely illustrated with Optos imagery. It's teaching Japanese interns how to do retinal detachment surgery. And important, we got many awards along the way, but one of the nicest ones from the Royal Academy of Engineering presented to us. That's my son there talking to the late Duke of Edinburgh, my wife, and this is me lecturing him on the importance of retinal exams. So anyway, there we go. Over to Derek now.
Thank you very much for that. Bit of echo there. Douglas, if you want to go on mute, thank you so much. Thank you. Let me just turn my camera on and share my slide deck. The time they've got remaining. So first of all, thank you for the invitation to speak this morning, and thanks as always to Douglas for your presentation. It's insightful as always, and I never tire of hearing that phrase of extravaganza of charlatanism, which I always enjoy. So for the remaining time, I just want to talk about how we've tried to maintain that innovation cycle at Optos. My name is Derek Swan, Chief Technology Officer at Optos. I've been there for just over 20 years now, so by no means right from the very beginning, but certainly a few interesting journeys over that 2-decade period. So, let's start with innovation and what we mean by it. Always trying to get clear definitions of what we're trying to talk about, and make sure that we can talk about innovation and separate that from the notion of invention. So what is innovation? There's lots of ways of describing it, but if we refer to that ISO handbook on innovation management, it's described as a new or changed entity for realizing or redistributing value, which I think is quite a concise and generic term. But what do we mean by the entity, and what is the value proposition, and most importantly, who is it for? Who recognizes that value? And that's something that was core to Douglas's mission and still remains at the heart of what Optos do today. So when we think about innovation, we tend to think about it in terms of the products and services that end up at the customer, at the value proposition end, which of course is correct, but it's also all of those underpinning, enabling things that allow that to happen. It's the processes, it's the model, it's the methods, it's the underlying technologies. And we think about the value and who it's for, it can be for a range of people, and that range can grow as a company grows. From the perspective of Optos, it is our customer, the clinician. It is their customer, the patient, for whom we started our journey in the first place, and it remains, again, at the heart of what we do. But it's also our people, our business, it's their career aspirations, their growth, their salaries. And let's not forget Abe Lincoln at the bottom there. It's also the finance, it's the business growth, it's your supporting investors, it's your parent company. And in reality, all of those things need to be satisfied and enabled by the correct innovation pathways and sustaining the right innovation framework. So, as a company grows, it can be difficult to maintain that pace, without a doubt. Your responsibilities grow. You have responsibility for legacy products, for a growing customer base, for new business growth, for your team, for the team growth, the team dynamics, and it can often feel as innovators, as a technology group, trying to compete in a marathon while running at sprint pace while juggling. There's a lot to think about, a lot to do, but you can't let that get in the way of the race, of the objective in where you're trying to get to. So how has innovation really evolved at Optos over the years? As Douglas pointed out, our foundations were really established on finding solutions to a very specific problem. And from that, we've seen growth of the technology and how that has helped patients globally over the last 30 years of Optos's history. So, throughout that time, our organisation has needed to respond to, very different dynamics, a very changing position of the organisation, and to overcome different barriers to avoid the pitfalls that can dull innovation over time. So, as Douglas pointed out in his presentation, our original foundations were built on this panoramic 200 device, starting from the concept. And this is the ellipsoidal mirror, albeit in tinfoil, which I'm not sure would work particularly well, in the concept of the first desktop device, the build standard 100, that led into the first commercial product of the panoramic 200 that gave the first imaging in the marketplace, the Optomap image, that 200-degree field of view. And at that time, as Douglas pointed out, it was really trying to gain clinical acceptance, market acceptance, clinical adoption to make sure that the value proposition was delivered to the patient, and the barriers could be financial, it could be supply chain, it could be the medical community itself. And that was the mission that Douglas and the team successfully overcame. Step forward to 2012, 2011, around about that time. And we're going through a bit of a reinvention, if you like. So in the bottom left here, this is kind of cartoon drawings of where we wanted to take this large floor standing device, keeping the value proposition, which is the Optomap and the unique field of view that offered, and all the benefits that can bring for early detection and diagnosis to our patients. How do you make that smaller, faster, lighter, cheaper? How do you make it more dynamic? How do you make it easier to use for our customer base? And that actually required us to overcome some very, very significant challenges in the technology, the methods, the processes, but most importantly, keep focus on what we tried to do and what the founding mission of the organization was all about. And that gave way to our Daytona product, which was launched around 2011, I think it was, around about 10 years ago, which was our first desktop variant that then allowed us to then move on to other variants and stratification of that product that allowed us to bring new imaging modalities, fundamentally drive that image quality forward. And this fast became our core device and drove significant global sales that has really allowed that commercial success to feed back into our investment and our innovation and growth over the 10 years subsequent to this. And actually, as Douglas pointed out, this device may be more in tune with the concepts and the early visualization that Douglas and the team had. So, innovation is a journey. It is a series of points, and it's a series of being able to knock down the barriers, but always with that eye on the core value proposition and never lose sight of that goal. And some 20, 25 years later, Daytona and the variants of our desktop devices were producing, I think, the Optomap image with the ease of use, with the consistency, with the scalability that our founding mission had always sought to achieve. So I guess, I'm very conscious of time, just, a few bullet points, and forgive me for, I'm trying not to go through these verbatim, which can be really boring for everybody, but just a couple of pointers I think that I've learned in 20 years of being at Optos, and how we can, as an organization, maintain that innovation cycle. The first, and I think possibly one of the most important, is context. Never lose sight of the problem that you're trying to solve. When you go through growth and you have the real benefit of increased revenue and increased funding in your technology portfolio, it can become quite easy to become technology led rather than solutions led, and invest in too many diverse ambitious projects that don't actually solve the problem that you're trying to solve, which is fundamentally, for Optos, saving sight and improving patient outcomes. That is what we need to do. That is our sole mission, and anything that gets in the way of that, we need to be brave enough to ignore, however attractive it might look. Also, as part of that, really understand the opportunities and solutions that you can offer your customers. Just because it's a good idea is maybe a good idea that someone else has already delivered. It may not be the idea that your customer wants. How do you shape that? And how do you make sure that you're always adding value to the endpoint, be that your customers and most importantly, their patients? And for us, it's about how we provide the most information to our clinicians so they can make the best decisions for their patients. So that's the comprehensive, patient-friendly, easy-to-use imaging solutions that improve detection, diagnosis, and management of retinal and systemic disease. And that's a very broad statement, of course, but it's really important that we just always think about that. Does it fit within that brief? And keep alert to influences, okay? So the market evolves, competitor solutions constantly evolve and can sometimes take you by surprise, as do your customer expectations evolve, not always through influences of medtech, but also commercial technology, consumer technology, how easy things are to use these days. It's all these influences you need to keep in mind. So don't be afraid to change your pathway as long as you don't change the goal, and make sure you make the right decisions for the right reasons when you manage your innovation pipeline. The second point here is really around focus and cohesion, and certainly over the last 20 years, this has been a really, really important kind of tenet for us to work to. It is easy, as I say, as an organization grows. You have different geographies, different teams, different ambitions, different egos, different directions. You've got to maintain that focus and that single point of drive towards where that goal is taking you. You've also got to try and maintain your unique selling proposition, your USP and your identity. There's been plenty of examples, and I maybe should have added a slide here of companies that have been known for doing one thing and one thing really, really well, that have diversified into completely ad hoc areas and confused their customers. So you've really got to think about what is it you're known for, and how do you bring your customers with you? So by all means, be disruptive, be novel, bring new innovation to market, but don't leave people behind and don't confuse them. So maintain that USP and identity. So it's got to be complementary, first of all, to the patient need, but also to your existing portfolio. Don't undermine yourself and keep that focus. And when I talk about focus, that needs to be organizational, right? So it's not about individuals focusing on their tasks. It's about the organization as a whole, keeping focus at all times and avoid pushing in too many directions. You need an organization of people that can balance that innovation and risk-taking with the pragmatism and level-headedness. You've got to keep that together. As I say, don't create these silos and hierarchies. Otherwise, it creates conflict. And the only certainty is the short-term growth opportunities and the short-term dollar figure will always win out, and innovation will suffer. So you've got to build that organization of balance of innovation, risk, pragmatism, level-headedness. And these are characteristics that each individual in your organization needs to have, rather than as separate functions. And as a point here, avoid the temptation of ad hoc diversification. Don't dilute your business. Diversify your products, but keep it focused. And I think Douglas is one of Douglas's opening slides of why bother. It's a really important question. So frequently remind yourselves why you're doing what you're doing and how much further you can go in solving the problems for your customers, in our case, our patients, as possible. And never stay still, right? So avoid complacency at all times. And try to be your own competitor. This is something that I work with my team on a frequent basis. How would you break your company's position? How would you undermine it? How would you take away that USP? How would you do better? Now, and by better, it doesn't mean to say that it's a wider field of view or it's additional modalities. What if it's 70% of the view but 20% of the cost? What are the things that completely could undermine you? Be your own competitor. Challenge yourselves. Avoid proponents of the status quo, avoid proponents of commercial inertia, and make sure when you find those gaps, you close them. Now, that doesn't need to always be through product. It can be through intellectual property, patent. Do what you need to do to make sure that you're confident on the pathway that you're on and that you're building sensible foundations for the future. Protect your knowledge and ensure you've got those foundations for growth. So there's more to your intellectual property than just patents. We need to think about protecting your knowledge base, write things down. Staff changes are inevitable, but an organization needs to keep that muscle memory. So you've always got, you're avoiding that need to relearn things that you've done in the past, avoiding repetition, especially repetition of mistakes. So I'm conscious of time, but I'm going to just very, very quickly run over the Silverstone story. So Silverstone is our latest product, and it kind of gives a bit of an insight into how we've taken those tenets of innovation management in Optos and how that's resulted in the product that we've launched a few years back, just before the COVID outbreak, in fact. So here's the problem statement. So Optos have pioneered and led this class-leading ultra-wide field technologies, and we have now become, with Optomap, as the gold standard in retinal imaging and fundus imaging, and we've built a very comprehensive clinical body of evidence with over 50 countries and I don't know, lose count of however many peer-reviewed publications that we've managed to establish. And as a result, we've grown our market share globally, and in our US market own top position in fundus revenue. However, looking to the right-hand side here, there's a technology called optical coherence tomography. Some of you may be aware of OCT, and it's a method of looking down into the structure of the eye. Thinking about like an X-ray, if you like, an optical X-ray or an optical ultrasound. It's a way of looking into the structure, and it was pioneered in the early 90s. But similarly to Douglas's story, these things take time to get traction, but when they do, if they're successful, things can change very, very quickly. So in the early 90s, I think around about 1991, it was OCT was first demonstrated in the eye, and that's an image at the bottom here shows some of that retinal structure. 10 years later, only about 180 units were sold, and this is from the Zeiss timeline, Carl Zeiss timeline. By 2000, the second generation of their instrument was developed, and approximately 400 units sold. Move forward 6 years, and there's 6,000 of their devices sold. And a couple of years later, 100 million procedures carried out worldwide, really prompted by the approval of Lucentis drug and OCT being a fundamental endpoint for measuring fluid accumulation, structural changes, for which was a determining factor of whether this drug should be applied. So it's a key aid in the diagnosis and monitoring of retinal disease across diabetic retinopathy, AMD, and glaucoma. So how can Optos enter this market while maintaining its focus in USP? So let's think back to our tenets of innovation. First, understand the problem you're trying to solve. Our problem is, how do we provide the clinician more information, specifically structural information, OCT, by which to make the best decisions for their patients? Number two, understand your USP and perceived value. We're an ultra-wide field company. We're known for our ultra-wide field fundus products, and we should therefore try and retain Optomap central to our customer offering and continue our USP of wide field and ultra-wide field imaging. Number three, identify the opportunities and solutions. Okay, so what if we could get that structural image from anywhere in the retina and try and keep that USP of ultra-wide field? What if we could correlate that with the Optomap image so that you're getting the benefits of both? But, oh, hang on, what if we actually use the Optomap as a foundation for image-guided OCT within the same seat time, within the same capture workflow, making sure that the clinician has everything at their fingertips that they need? And that then drove us through quite a challenging set of technology blockers to get into a system, our Silverstone system, where you can acquire an Optomap and then freely make a decision on wherever you want to go to examine that underlying structure. And you can do that in an automated way, where it will just sequence through, or in a bespoke way, where you want to actually look at specific anomalies. There's some examples here where we're showing the Optomap, and we're showing these structural segments that have been taken at various points around almost the entirety of the retina. And that, coupled with the additional imaging modalities that Douglas referred to earlier, our autofluorescence looking at metabolic health, our fluorescein angiography looking at vessel health, all of those combined have really led us to a really comprehensive, easy to use imaging platform, taking that journey the next step ahead. And this example at the bottom almost comes full circle to the problem, the statement that Douglas was trying to overcome. Here we see a peripheral retinal detachment. You can see it in the Optomap as this bright lesion here, But in the OCT, you can actually see that structural degradation and that retinal detachment pulling away, which again really helps the clinician understand what treatment pathways, monitoring and management pathways they want to take. So I come back to my first slide, and what is innovation and what is it for? And specifically, what is the entity that realizes and redistributes value? And for me, it's you. It's the people. It's the organization is the entity. It's not the technology. It's not the methods and the processes. Yes, these are all part of it, but the entity that needs to realize the value is you. And the people that you're realizing it for, you need to be dead clear on that. And for us, it's always been about the patient via the clinician, via our team, and of course, the financial aspect has to be there too. So innovation, or the realization of inventive value, is achieved by everybody. Build a culture of innovation from the ground up at an organizational level, built on mutual respect and support of everybody that is achieving our shared goals, with a focus on the patient or customer need at all times. Thank you very much for that, and apologies if I run over a little.
Absolutely not, Derek. Thanks so much. Yeah, both were absolutely compelling. We have run over a little bit. I can see by the number of people who've stayed that it's been compelling for them too. We do have a couple of questions. It would be good to go. So Jan Tiefenbrunn asked a question first. Jan, do you want to come off mute and ask away, or do you want me to ask it for you?
Yeah, as I said, great story, great journey. Something I can relate to from a business startup side. The question we've got for you is, how did you overcome the initial period of that great idea but no money, and how long was that period for the business?
Oh, you're on mute there, Douglas.
Off mute. I think it was 17 years. That's how long it was. How did we overcome it? A lot of arm twisting, And I would say, in my own defense, very, very good investor management, telling them the truth every day, never any false hope, usually emphasizing the problems rather than the successes, until they were fully entrapped. And they were entrapped. They invested money laterally that they absolutely didn't want to invest and they didn't have the money. But, there was too much to walk away from, both financially and spiritually. It's worth saying that at the end of the day, the people who really stuck it out got 60 times their money back. And let me just say that was, obviously, it's partly to do with technology, but the business model, my business objective was to make the technology ubiquitous. And that's just a one-word mission statement. To do that, you have to have absolutely every aspect of your ducks all lined up. You have to, people want it, can afford it, and the benefit has to be delivered in it. There's so many things there. But given that you have managed to struggle to that point and investors can see it, well, why wouldn't they just hang in there?
Brilliant. Thank you, Douglas. A couple other. So, Derek, if I can point you, we've got a question from Daniel Banks, which is quite detailed. I don't know if you can see it. And it may be one that you might want to take a connection afterwards, or do you want to have a go at answering it just now?
Yeah, why don't we take Daniel, if you
we can connect you to him.
Yeah, if you want to just connect to him, then absolutely. Let's talk about that.
Let's do that. And Daniel, I hope that's okay. But it's quite
it
deserves a good conversation, so we'll connect you there if that's okay.
I'm doing some work with my mutual acquaintance who has a technology business and is a friend of Sir Jackie Stewart. So we're trying to use technology of any form to get into this dementia, which they have handles on it. They've got research fellows all over the world. So we'll talk about that afterwards, because it is something that's close to my heart as well, Douglas. It affected me personally. My wife is still at home, but we're having other issues going forward, and it's a slow slide. So I do feel your principles. Okay, so we'll talk. I take it, Paul, you've got my email address.
Yes, we've got your email address, Daniel, and we'll do the connection from here.
Yeah, and
Okay, thank you.
It's certainly an area that I'm really interested in, just thinking about that overall visual function and what opportunities there are. So by all means, let's just connect afterwards.
Okay.
Great stuff. Gordon Masterton, can I ask you, can you come off mute and ask your question? That'd be great.
Thanks, Paul, and Douglas, great to see you. I think there's another anniversary this year, because I think it's 10 years ago that we inducted you into the Scottish Engineering Hall of Fame. And more to the point, you were the first living inductee. So good to see you're still fighting fit. I couldn't help but recognise the analogies with another inductee, James Watt, because nobody could afford his improved steam engines with Matthew Boulton in the early years. So they devised, in effect, a leaseback system where they only took payment for the improvements in efficiency that the users realised by using their improved engines, and they had to measure they had to fit equipment to measure that on their machines, so advancing the technology. But the other thing they relied on was precision engineering. And in the early days, they didn't have it. Nobody could make the machines as precise as they needed to be until they encouraged the technology to advance, and people like Wilkinson made breakthroughs in the precision required. Now, what's your advice about, whether to rely on the market to deliver and other parties to advance to develop critical capabilities on which your innovation is dependent? Because you touched on that, I think, in the talk. And should you have faith that others will succeed, or should you invest in others to help them succeed, or should you just take ownership yourself and do it yourself?
Well, I can speak to the first 10 years, and I think probably for 3 or 4 years we did rely on others, and when they let us down, we actually positioned teams in their factories to try and overcome their difficulties and ensure that they operated to the level of manufacturing precision that we needed. And when that failed, we then brought it in-house insofar as we could. So if your business is absolutely dependent on the supply chain and the supply chain is failing you, well, what can you do? You have to just go in there and sort it. And we spent millions sorting other people's problems. No question about that.
Well, thanks, Douglas, and Gordon. Thanks for the question as well. I think we've done pretty well in stretching your time today. I'm going to, one last question that was put in chat by Paul Sweeney, but I'm going to ask Robert Kennedy to pick that up, as he's offered to do that.
Hi, just by way of introduction, I'm Rob Kennedy. I'm the CEO at Optos. Have been for the last 7 or 8 years or so. So yeah, just Paul, your question. I think certainly in the early days, Scottish Enterprise Agencies did help with some funding. They also, I guess, was really important in terms of they matched the funding that came from the Archangel as well. So that funding helped to provide that investment. I think they were a shareholder in Optos for quite a long period of time. We also made use of the sort of manufacturing support and things like that. I think Sarah's actually on the call here. I think certainly we're involved in the manufacturing support agency as well. I guess what we sort of your last comment, which sort of reads as negative, I want to be clear: we're not a branch. Actually, we are actually still a hub of global corporate control. So actually, the Nikon acquisition, we were a listed company. That has positive, but also it actually has constraints as well. And actually, I would say since we were being acquired by Nikon, by and large, actually, they've been a really valuable parent company and allowed us to grow and invest in a rate that we probably wouldn't have done had we still been independent. So we have doubled the size of the business, probably added probably about 40% more staff in Scotland in terms of our R&D capabilities as well. So I think so we're definitely not a branch. We're actually still a world leading area, and that's allowed us to invest. And more than happy we want to have a separate conversation about that separately in terms of government support and things like that. But I think it's it's as an organisation, as any organisation, I think it's about having the right partners and right investors to allow you to grow and build as an organisation. I think, and actually for us that it's been really successful since that time.
Rob, thanks a lot for that. Everyone on the call, thanks so much for turning up this morning. We have stretched our timeline, but I'm sure you've all seen it as hugely useful and compelling. Douglas, thanks so much. Derek, really appreciate your support. Thanks also to the Institution of Engineers in Scotland for coming forward and suggesting to do this. It's been a great idea. I hope you all enjoy the rest of your day, and thanks again. Enjoy. We'll see you all soon, I'm sure.
Thank you, everybody.
Thank you. Bye-bye.